So now I'm going to talk about the datagram switching technique. And we said in a datagram, you take the message, break it into smaller packets, we call them datagrams, put a header on each packet. That's not part of that. That's another disadvantage of this here. The way you're going to evaluate how good a technique is. See how much extra weight, extra data it needs to send. That's not part of the user data. Okay? So it's like maybe flying. Sometimes they say, okay, you have to pay maybe for any extra weight on bags or luggage or whatever. So that's extra cost. So same here. Let's say if a channel can deliver 1 million bits per second, and you have 1 million bits, but don't forget you're going to add more to it. You're going to have the headers. So it's going to take a little bit longer to deliver the header information and the actual information. So any technique that takes more than the actual data, then, you know, if it's too much extra, that can be a bad. So it's a bad thing to have all these headers. And the headers can get big because you have to have IP address of the sender, IP address of the receiver. Yeah, there's a lot of information that we'll go through. And the headers can get quite big. And because you're sending a million packets or datagram per second, that means you're also sending a million header every second. So they can build up the amount of data. Right. So, but anyway, that's how it works. So describing it, and from the way we describe it, you can extract the features or the advantages and disadvantages. But that's how it works. You have a message to send, a file, break it into small units, and give them sequence numbers on the header. Number them. Why number them? So the receiver can put them together in the correct order. And just give them to the nearest router. You're also, wherever you are, you're always connected to a router. At home, there is a wire that comes into your house that connects you to a router outside. And that router is connected to another router. And all the world is full of routers. Routers are just like airports for us traveling. But you can think these are airports for packets. And so anytime you want to go from here, say, to Japan, you want to travel, you need to jump from one airport to the next. Your data that you want to send to Japan will go from one router to the next. So a router considered like an airport for people, for a router for data, for information. So anyway, you're connected to a router, like here, we're in Dublin, there's Dublin Airport. Yeah, if you want to travel outside Ireland, you have to go to that airport and jump. And you can only fly wherever, even at airports, wherever we have a flight direct to. You can't say, oh, I want to fly to Tokyo. There's no flight to Tokyo from Ireland. So if from Ireland, you can go to London, Madrid, Rome, for example, Istanbul. These are the only locations. So you have to go to one of these locations and look from that next airport, where is your next, the new destinations that you can go that will bring you closer to your final destination. That's how data communication happens on networks. So, but there's no request, as you notice here. You don't ask, I want to talk to somebody. No, just give us the data and we deliver it, just like the post office. So anytime you're asked about datagram switching technique, think of the post office. You don't have to talk to your friend in Australia, can I send you a letter? No, you just put the letter in the post. Your friend in Australia doesn't even know they're getting a letter from you. But remember, it also, if that letter got lost in the ordinary post, you don't even know if it's lost. If it's delivered, you don't know if it's delivered. So that's how the datagram works, just like the post, the ordinary, like imagine you go on holiday to Spain and you send your friend in Brazil a postcard. You say, oh, I'm in Spain, I'm enjoying the weather. You put it in the post office, that's got lost. You don't know if that postcard got to your friend or not. We call that acknowledgement. So there's no acknowledgement in datagram. There's no confirmation that your message was delivered or was not delivered. So this is one of the features in it. It's a disadvantage. Of course, it would be nice if you know you send a message that got delivered. The datagram switching technique does not do acknowledgement. In fact, the datagram switching technique Does not do a call center. Does not protect you from people who want to send you messages. Anybody in the world can send you messages anytime they want. It does not, when you send a message, it does not acknowledge you that your message got received or not. We call it negative acknowledgement or positive acknowledgement. But there's no acknowledgement at all. What else? If your message developed an error, like during transmission, one of the bits ones turned into a zero. It could change the meaning of the message. And it got delivered. The datagram switching technique doesn't care and does not fix that error. Doesn't even tell you there is an error in it. If you want to build your own systems, that's fine on top of that at the end. So that's why the datagram switching technique that's used by the internet spread so much, because it does very little, and therefore it's very cheap, and therefore it doesn't need big computers with big processing, because it doesn't do any error detection, any acknowledgement, any losses, nothing. It doesn't. You just send the message, and they call it effort, the best effort service. That means we do what we can. That's exactly what the post office is doing. The post office, when you send a letter, they do what they can to deliver it, but there's no guarantee it's delivered. They don't acknowledge it to you, and if it got lost, they don't tell you it got lost. That's how the datagram switching technique works. And that's why it's successful, because it doesn't need powerful machines, because they don't do anything. They don't do error detection, they don't do acknowledgement, they don't do any calls. They just take the message, break it into smaller units, and dump them to the nearest router. And the router gets them and just forwards them to the nearest router. It doesn't even do any error detection. So quick. It works quick. It doesn't need powerful machines. And that's why most people around the world over the last 50 years, well, the last 20 years at least, it's been around since the 80s or 90s, since the 90s. It works fine. Not good, not great quality. That's one of its features, again, disadvantage. It doesn't have great quality because sometimes things go slow. You watch a video, things go slow. Why? Anybody knows why it cannot guarantee a good quality all the time? Any idea why datagram does not always allow good quality of service? Anybody? Datagram?
Because it's slow. Maybe it's slow because you have to wait that all the data routes reach the other side.
No, all networks, if you're watching a video, you're downloading the video from some location in, I don't know, in Canada, and you want to watch it. But are you watching it, are you using internet or datagram switching technique, or are you using, the other circuit switching technique? With the datagram, maybe you start watching a video for a little while and then suddenly it might start interrupting. Why? We say the quality of service has gone down. That means the speed is low. Any idea why? Pardon? Because there is no limit on the users. Any start using the network and they start sending data. And therefore, because there's no limit on the number of users, you could be watching a video for 15, 20 minutes, an hour, and then suddenly, lots of people decide to start using the same network, using the datagram, sending data, and now because the channels are shareable, that means they're shared with you. It's not just this link that we have, this satellite, this wire, is not just for you, anybody's data. It's not dedicated. The lines are shared, and the number of people can change anytime. So if the number of users increase, and the amount of data increases that they send, then it's going to affect you negatively. So this is what I need you to remember. Why does the quality of service go low? I mean, why is you're not getting data quickly? And the clearest thing is with a video. If you're watching a video, you need continuous good supply of data to watch the video. Suddenly, it starts getting interruptions because there is a lot of people using, or a lot of users are sending a lot of data on the net. All right. And so I'll say it very briefly again. If you want to send data, sometimes you're asked to describe it. Maybe it takes 3 or 4 statements to describe it. First, you say, a user sending a file or a data must break it into small units. We call them datagrams. And every datagram will have a header. And the header, every datagram, every header on every datagram, we must put source address and destination address and a sequence number. So every envelope or every datagram is independent, self-sufficient. It carries its own destination. It's just like the post system. Every letter you write on it who you're sending it to. And then just give all these to the nearest router. And the router is connected to many other routers, so to pick whichever one is a good one. So it might send packet number 1 and 2 and 3 to this way, to this router. And could send them all to this router. But everyone is independent. If it notices this route is getting really slow or bad or broken or something, it's this one. And these might change even in opposite directions. And eventually, they go around the world from one router to the next until they reach the final destination. And here's the user there. So the user start getting these packets. Sometimes it gets them in the wrong order, 1, 2, 4, 3. For some reason, you might get number 3 or 4 before number 3. So it's a user problem. At the end, they have to sort them out and then get rid of all those packet headers. They have to be removed and put the rest of the data together in one file. And here's the file sent. But it can be very fast, obviously, because we send everything through main memory of the computers. We don't store on a hard disk at every computer. Like the message flies from my memory, my computer's main memory, to the router, and it just keeps going. And it gets there in maybe to Australia in 1 second or less. So that's how good datagram is. Okay, it's not always good. The quality of service is not good. Okay, just to keep this idea in your head, in datagram, did we make a call request? Did we send a request to call the other party? No, it does not have a call request. Is this good or bad? You don't have to call the other party. Say, hey, we're sending you messages, and they say yes, and then we send. Is this good that we don't have to do the call setup? Why is it good? If we say, oh, it's a good thing, why do you think it's good to make a call setup?
Because I don't visualize, so I receive it first.
Yeah, because or from you, well, then I can say no, I don't accept. But in datagram, you can't say that because anybody can send any messages to anybody else without requesting them. But some people say no, not having a call set up is a good thing. Why is it a good thing? Any idea? In datagram, if I want to send you a message, just take the message, break it into datagrams and send it. No need to call you. And somebody says, oh, that's an advantage. It's not a disadvantage. Why? Any idea why? No, not having a call setup can be an advantage, can be considered an advantage. Why waste time calling somebody? It might only take 1 second to call. But hey, by the time this guy, where they have to do a call setup, they do a call in 1 second, I can finish sending my message in half a second before they even start sending the message. Call setup can take 20 seconds. In 20 seconds, we can send 20 million bytes. So if your message is only 1,000 bytes, you can send it in very short time before the others even made the call that they need. Okay, so having to make a call setup or not doing it, sometimes can be a good thing, sometimes it's a bad thing. It's a bad thing because we can say that's a waste of time doing a call setup. It delays, a lot of delay. Right, but datagram, are these links shared or dedicated? In datagram, they are shared. Is that a good thing or a bad thing? Sharing links in a network. It can be bad or good. What's bad about sharing links? It can slow you down. So if you want to send, watch a video and other people start sharing the same links and they also want to exchange videos, then the link has certain capacity. If too many users are using it, it's going to slow down. So sharing links can be bad. But sometimes people say, no, sharing is a good thing. What's a good thing about sharing? Cost. Cheaper. It's a lot cheaper. Because on the datagram, you can have 10,000 people using this network, and therefore the cost is minimal. With the older telephone systems, if you have to use dedicated lines, it costs so much. Telephone communication used to cost a lot of money. All right, but telephone companies came up with a new idea. They said, hey, we don't want to use the circuit switching that we used to have in the old days. Now we're going to use virtual circuits. Yeah, we're going to use a circuit, but the word virtual circuit, the word virtual means almost a circuit, but it's not really quite a circuit. It's like virtual reality. It's like reality, but it's not really a reality. So the telephone companies, they started sharing their lines as well. But so this is the way, the last technique, number 4, virtual circuit switching techniques. They say this is the way it works. This is like the old telephone techniques, but this is modern telephones. That's what the new telephone companies came up with. They said, remember, the users are always, anytime we draw a network, we draw kind of the routers or switches in the middle, and users are on the outside. So these are all users connected to the same router. Remember, just like you at home, and all your neighbors are probably connected to the same router. That's how most textbooks would display data networks. The actual devices of the network in the middle and the users from the outside. But just to make things easier. So normally, this user here wants to send a message to that user. Or this could be a server where there's a video and you're here. So you want to download that video coming down this way. Or you want to send a file from here to this user or from there. So that's why those links are shared a lot. So now, this is how virtual circuit, this is how the telephone companies now, the idea that they came up with. They said, okay, every time somebody wants to send or start sending data to someone else, they must do a call setup. So the 3 phases are still there. Call setup. Then if your call is successfully set, then you can start send data. And when you finish the call, you must do a call clear. Finish that call. So they still use the same technique, but how? With the newer techniques, so if you have a computer, you want to use virtual circuit. I mean, let's say you want to send information to that user there. This guy must send a call request to the router. And every router here will have a list, usually an array in its memory, that has, for example, 5,000 or 10,000 records. And every record here will indicate a telephone call or a communication. So for example, this user A wants to communicate with user B. So you send a request. A request is just like a packet, one single packet. You give your address and the address that you want to call. Like the IP address or the phone number, your phone number, and I want to call this number. But let's use addresses. So this guy makes one packet, like the datagram puts in the header the IP address, the sender, the receiver addresses, the sequence number. This one just puts the addresses. This is my address, I want to call this number. And this goes to the router, the nearest router. You don't send any data yet. So the router looks, do I have a free entry in this table? Like these are all the calls that are at the moment running. So it says this is busy, and he's free. So yeah, to give you this one. maybe at line number 23 or record number 23 in the array, in the table. It says, right, okay, then A, and it puts the information there. This user wants to talk to this user. And remember, every router or a switch has at the back ports, just like computers. They have ports at the end. They say, and this call came to me at port number, whatever it is, let's say 5. This is the port number here. Port number 5, and I'm gonna put it through this port here, number 2. And this is busy now, from now on. It's a call being built. It's not on yet, like in the stage of being set up. And it takes the call request and sends it to this router. It decided that's a better router than this for this call. Forwards it to that router. That router also has its own calls that are going through it. There could be that user's going there, this user going there. So now gets a new request. It looks for another in its own table. This is, say, for example, number 103. It's a free entry here, so it says, yeah, A wants to communicate with B. I got this in my port number 7, and I send it to port number 12. So now this router knows about this call and forwards and say, okay, can I send it that way or this way? Let's say that's a better way. So it sends it to this router. So this router gets it and puts it into its own routing table and has a number there, let's say 88 in its table. This is like you booking a holiday. Imagine if you want to book a holiday, you want to go to, where would you like to fly to? Singapore, right? Yeah, I like that's good. So first, you need to book a flight from here to London. So you call Aer Lingus, and they give you a code, a booking code. That's the one that we'll be getting there. That's your entry into that table. And then when you get to London, then you fly to Dubai on British Airways. So you call them and you make a booking, and they give you a booking code. That's like here, British Airways, that's London. Well, that's the next airport. And then the next airlines will fly you there and they give you a code. So now you have 3 or 4 flights you need to go. And you have a code for each one of them. So if this guy eventually gets the request, he'll send back a packet and say, yeah, I accept. Just mark it as being accepted. So the packet comes in here, and this router will update its entry, says, yeah, this call has been accepted, and sends that call accept to this one. So it will return, it will follow the same route, because it will know which line it will send it back to. And this one will mark the call that's been accepted and forward the packet to that one. See, it gives it the number 107. This one is 88. And then this one, you get the final code from this one, let's say 102 or something like that. So we get number 102. This guy gets number 102. Your call is accepted, and here's your code, flying code. So all you have to do on that date, remember this link is running with taking other people's as well, just like airplanes are flying with passengers all the time. They're not all booked for you, but there is one flight when you get the date and the time. So this guy now takes the message, breaks it into datagrams, and puts a header on the front of each one of them. And what does they put on the header? That number, 102. That's the booking code. We call it the virtual circuit number, but it's the booking code. And a sequence number, 1, 2, 3. But you don't have to put addresses anymore. Why? Because when you, on the day of your travel, you go to Aer Lingus Airport, and you go to the desk that check in, and you show them, you tell them, hey, I have flight to London. And say, show us your booking code. You show them the code, they enter it, they say, oh, we know who you are. You're Tom, and you're flying all the way to Senegal, whatever. You're going to London, right? Okay, go to line number, go to that gate. They send you out to the port number. So they already have all that information. So, and they send the packet there, and that packet, when it gets to the router, it also have its own code. 102 is replaced onto the packet, on the head of the packet. And you get to London, and you go to British Airways desk, and you say, I have a flight to Dubai. And they say, okay, show us the code. You give them the code, they know. They know your name, they know your details, your passport, everything. They have your information. They know about your call, they know about your holidays. And then they tell you just directly, go to gate number 28. and you go to gate 28 and hop into it, and you go to the next airport. And that's how it works, and exactly that's how a packet moves. Every time it gets to a router, it will look at its code, the virtual circuit number in this case, and say, okay, I need to put you onto this link here that takes you there, and it will take that code from 102, put it in the header instead, and send you out. This router finds 102, that's the code for the next flight. It puts you onto the next one and change the code 88 and so on. And every packet here will have the same code and sequence number. That's all it needs, the code and the sequence number. That means if you have a family member traveling with you, possibly they all have the same code. They all walk to the airport, it puts them onto the flight, send them to the next one, and they can produce the code for the next one. So now, these links here now are shared with all the data that's coming from any other direction. It's just like you flying on an airplane. It could be on the same flight, somebody going to Rome after that, and then from London it could be going to Madrid, but you're going to Dubai. So at every airport, the packets go in different directions. At every router, every packet has its own booking route. The router knows about each packet that belongs to a communication because somebody at the start, they made that call setup. And when you finish sending all your data, either the sender or the receiver can send one packet and say, hey, this call I made that I have the booking code 102, please, I'm terminated. So it's terminated. And the router goes out to your record, to its record there, and removes your name. But just mark it as being, so maybe someone else can take that booking. So that's how the virtual circuit works. Every time you want to send a message, this is very brief. Every time you want to send a message, you break it into packets. But before you send any of these packets, you send call request. You put your address and the destination address. You send it to the nearest router. The router will look. Does it have a free space? Now, this is how it controls. This router, for example, says, I can handle 10,000 calls without any delay. So it has a table of 10,000 entries. 10,000 names can go into calls. If these are full, right now it has 10,000 calls, it'll say to you, sorry, I can't take it. So you might be refused. Why? They might refuse you in order to guarantee the existing calls that they are okay, they have no delay. The datagram does not do that. The datagram, there is never a refusal to anybody who wants to send data. So that's why the datagram cannot guarantee you good quality. It depends on the number of users, but with the telephone systems, with the virtual circuit, they say, we're going to give you your own kind of circuit, and we guarantee you're going to have a good quality of service. Even though it's shared, but how do they guarantee a good quality of service? Because they can control how many people can share this network. So if it reaches a certain limit, they will refuse new calls. That's the only reason why they can actually guarantee a good quality of service. But that's how the virtual circuit works. So my question, is this virtual circuit, does it share these links or are they dedicated? Who wants to answer? In this technique that we talked about, are the links shared or dedicated? Shared, they are shared, but the number who are allowed to share them is limited. Okay, so limited by say 5,000 or 10,000. So enough to give you a good quality of service. With the datagram, the technique used on the internet, this here, they're shared as well, but there's no limit on the sharing. Anybody can use it. Sometimes goes to 20,000 people, then things goes really slow. So the telephone companies came up with this idea. First, the old phones use a technique called the circuit switching. It's not good. It's the only technique that has dedicated links. The old telephone technique, if you're asked about it, to describe it, there's a network, but if you want to send data, you must first dial a call, do a call request, and you're given the call request, if it's made, then the link is yours, it's dedicated. But with the virtual circuit, we give you a route. You cannot change the route. Same in booking a holiday. If we book you from here to London, to Dubai, to Singapore, or wherever it is, then you cannot change it. If in your flight from here to London, the strike was on, you missed that flight. Tough luck, you lost the entire flight. That's same with virtual circuit. If part of this circuit breaks, you lose the entire call. What about in datagram? The one that's used on the internet. If the router is sending all your packets this way and this link breaks, what happens? You don't lose the call. This router will just change to another route. You know, there's no booked route for you in the datagram. So in the datagram switching technique, it's flexible. We can send you any route we find. The fastest route, let's switch to it. With the virtual circuit, we look for the best route for you. But once we book it for you, we cannot change it. It cannot be changed during the call. If we change it, you have to cancel the call and start another one. It's like booking a holiday that you are not allowed to change your routing. And if you miss that flight, that's it, you lose the whole thing. Okay, so now, right now in the world, these two techniques are used. Right, I mentioned the distance vector routing, and I mentioned the circuit switching. These are all techniques. These are the techniques that are used in today. The datagram, it's used by the internet. The internet that most of us use today, we use the datagram switching technique. The virtual circuit is a technique developed by telephone companies, and it's used by some high-speed networks. Usually, they don't end up to the house user, houses and end user. They deliver data at high speed between other networks. Like there are networks that carry networks data rather than individual users' data. Okay, so which one is better, the datagram or the virtual circuit? We start by making it easier. Yeah. Okay, the links. Which of these techniques uses those two, only those two? Which of those, the links are shared, and which of those, the links are dedicated? Anybody knows? Are the links in the datagram, are they shared or dedicated? Shared. So don't forget this, they're shared. What about the virtual circuit? This technique here. Shared or dedicated? Shared. Okay, be careful, guys. Level of sharing is slightly different. This one is unlimited. This one is limited. That's one good thing. If you lose a link on the datagram, what happens? Do you lose the call? You just change the route. You don't even know about it. The routers will find another route and will send or route the rest of the packets in another direction, and they will reach there. So with routing, this is flexible routing. What about this one? Is the routing, is it flexible? Datagram and virtual circuit. Right. Shared? Yes, they both use, the links are shared. Flexibility. Flexible route. With the datagram, if this link breaks or slows down a little bit, they find a better route and they switch and they go to it. With the virtual circuit, no, you cannot change the route. So virtual circuit, no, it's not flexible. Yes, very flexible with this one here. Which one guarantees the quality of service? Which of those two techniques will guarantee the quality of service? The datagram? Does the datagram guarantee the quality of service, or virtual circuit guarantee the quality of service? Sometimes, don't say the datagram does not give you good quality of service. Sometimes it's great. Sometimes you watch a video at home and you know you're using datagram, and you can watch the entire video without any delay. The quality of service can be good, but not always. I don't know. So which one guarantees the quality of service, or which one does not? The virtual circuit one guarantees the quality of service?
Yes.
Yeah, that's correct. So quality of service guaranteed. Quality of service, they write it QoS. It's guaranteed by virtual circuit. By datagrams, not guaranteed. Okay? Sometimes good, sometimes not good. Why? Why the datagram cannot guarantee the quality of service, while virtual circuit can guarantee it? You say in virtual circuits, if the number of users increase, new users will be blocked. But the datagram what? The new users? Yeah. So the quality of service cannot be guaranteed because it never says no to users. It never blocks users. This one can guarantee a good quality of service if you're asked why. And there was a question in the exam. Why does virtual circuit, it can guarantee a quality of service? Because if the number of users increase, it can block them. It can say, sorry, call now. Because we already have 10,000 calls and we want to maintain good quality of service for existing calls. All right, what else? But there are other things. Datagram, does it give you acknowledgement? Does it tell you when your message is delivered? No. And it does not fix errors. The telephone network, well, the virtual circuit, it actually guarantees the delivery. Well, it doesn't guarantee, but it gives you an acknowledgement. It tells you your message was delivered. In fact, every time this machine sends a datagram to this one will say, okay, I got it. Don't worry about it. And then when this one sends it to that one, if there's an error, it says, sorry, I didn't get it, it's not correct. Can you resend it again? So it sends it again and says, okay, I got it. So acknowledgement is always there. And you're guaranteed that your message will be delivered, or at least you get an acknowledgement to be told, oh, sorry, we lost the call, or we lost the link, or something like that. Okay, which one needs a call setup? You need a call setup in the datagram or in the virtual circuit. Does the datagram switching technique require a call setup? This one here? No. So no call setup is required in the datagram, but in virtual circuit, yes, it must. You must do a call request, and so on. So, but differentiate between the features, how it works, and the advantages and disadvantages. How it works. So just again, one last time. Sometimes you're asked, you can describe it in 3 or 4 statements. The datagram is how you should describe it. Before data is sent, it's broken into smaller units called datagrams. Every datagram, you append a header to each datagram, and each datagram will carry the source address, destination address, and a sequence number. And it's all given to the nearest router. You can say no call setup if you want to say it, but you don't have to say it. Just in case there is, right? And then you give it to the nearest router. You don't have to ask no questions. The router will not ask you any questions. Take them, and we'll try to route them to the nearest router, and then route them to the nearest, and they keep going until they reach the end. That's all description. Now comes the rest of the questions, or advantages, disadvantages. If one of them is lost, you don't know about it. That means there's no acknowledgement. And if one has an error, but it got moving, it doesn't check it for errors. So datagram doesn't do nothing. And think of it, this is the datagram you're using now. And why everybody is using? Because it's so cheap. The links are shared, and it doesn't do any work. It doesn't do It only delivers as the best possible, they say best effort service. If it can deliver it without error, great. If it develops error, unfortunate. If it's lost, it's unfortunate. And you will not be acknowledged. So really, it doesn't do much in the line of technology, but it just delivers and it's very cheap. The virtual circuit, it does error detection, it does acknowledgement, and it does call setup. But your device has to be strong and powerful enough to do all these things and every other device. And therefore, all devices need to be slightly more expensive in order to get use of it properly. And that's why it's not very commonly used around the world with ordinary people. Right, I want to show it to you now on the machine. Any questions so far? Okay, while I'm getting this, can you tell me which one is better, virtual circuit or datagram? Which one would you prefer? Very good, very, very good. All right, let me tell you something. I only have very few messages, and my company, I want to send advertisements to people. Which one would you recommend? Why? Why would you recommend datagram? If I want to send advertisements to, if my company is an advertising company, I want to advertise material to people. Why would you recommend datagram? Because? Okay, because it doesn't need a call setup. You don't need to set up a call. All right, guys, let's listen to me for a little while, just for 5 more minutes. Kamush, kamush. I forgot the Turkish word for it. All right, here's the switching technique. I'm going to fly through it, but you have this on Moodle, I think. So there are four switching technique. Now, I'll get to this another time, so I want to go straight into the switching technique. This is around the world. These are all little local area networks that your message might have to go through so many of those in order to get there, or might go to a satellite and back down the other end, or whatever way, but it will get there. And routers are the ones that really connect the world together. All these switches are connected through routers. Now, this is the first technique, the message switching technique. This is done by computer companies, but the first attempt of communication. They take the entire file, they want to send it to another machine. They transmit it to the nearest machine, they store it. At the time, they only had tapes. So they have to store it on a tape. And it goes, once it's fully received, a copy of it is sent to the nearest machine again. And if there's an error, you'll ask it to retransmit it. It might take half an hour to transmit and receive. Sometimes more, an hour, 2 hours sometimes, but eventually it will get there to the other end. This is called message switching technique. It's very slow. Why is it very slow? Why is this technique very, very slow? Yeah, because you have to store that data into external storage devices. Mechanical devices are very, very slow compared to the electronic main memory. Right, so let's go to the next one. These are some advantages, disadvantages. You should understand it by now. This is the improvement of the message switching technique. This is what computer companies came up with. Back in the 70s or 80s, they came up with this idea and started using it. That's breaking the message into smaller units with a maximum size. That maximum size will fit into memory. And memory started improving. So you break the file into messages, put a header onto every message, into every datagram, put the source address, destination address, and sequence numbers, and dump them. Don't even ask, just throw them to the nearest router. It will never say no to you. And this is an important feature, that it can lead to bad quality of service. So all the packets are sent to the nearest router. This router will find the best route is coming this way, but sometimes things delay, so a packet might go in a different direction. They all reach at the other end. All these headers are removed. Make sure they're in the correct sequence and put them onto your hard disk or whatever it is. It takes seconds compared to hours. This is a big development in computer communication, in communication worldwide. Now, the links are shared. Route is flexible, and robustness. Anybody knows what the word robust mean? The system will continue to work despite some breakdowns. So even if some links break down, it will continue to work. This is an important feature. We'll need it. It's called robust. So a robust system is a system that will continue to work even if parts of it stop breaking. So if while you're sending your data, this link breaks down, the datagram will switch to another link and will continue sending your message. This is called datagram switching technique. Look at it one more time. That's the datagram switching technique. Breaks packets, send them. Some packets might lag behind. You get the wrong sequence, 1, 3, 2, 4. You need to reorder them. That's another disadvantage. If I ask you, what's the disadvantage of datagram? It works, but disadvantage, sometimes the quality of service is not guaranteed. Sometimes it's good, sometimes it's slow. The packets might get out of order, might arrive out of order. But don't forget, the lines are shared. Is sharing lines a good thing or a bad thing? What do you think? Sharing links. It has a good point when you share links, but it's also had a very bad point. Sharing makes things cheaper, but the quality of service drops. Right? Keep that in mind. Right. The next one, we'll talk about circuit switching. I have another video of circuit switching, so we go straight into the datagram switching. Come on, get in there. So this is the datagram switching. We're going to send a file from one end to the other. This is what the telephone companies came up with. We said, right, let's break this into units as well, but don't send them. Send one packet. Send it to the nearest router and put the source address and destination address in that request. And every router takes a note of that. And a route is almost plotted for you. This is like booking your holidays. You already, once you make the booking, now you know your route. But remember, it's not dedicated. Be careful. Be careful. There's only one technique that uses dedicated links, and that's the old circuit switching technique that the phones use. But the new virtual circuit, all the links are shared as well. Even though I drew the line here red, but just to let you know, your route is firm, it's fixed. But it's not dedicated. Many students, they use the word dedicated in the exam, and that just drops your marks completely. So be careful. In the virtual circuit, the lines are shared. Don't forget, it's written there. Quality of service, pointing up, that means it's good. Flexible routes, pointing down. I mean, like in a holiday, if you miss one of your flights, that's it. The whole thing is cancelled. Same here. If this link breaks down, your call is terminated. You can't resolve. Even when the link is fixed, your call is gone. You must start a new call. So it's not flexible with routing. And it's not robust. Robust, if you miss one of the links on your call is terminated. So now the receiver must send an accept that confirms the booking. Otherwise, it will send a refuse. And now we can start sending the packets. Every packet will have the virtual circuit number. That's like the booking code. And they all go. And most likely, and obviously they follow the same routes, and most likely they'll arrive in the same order. Okay, occasionally there might be an error when it's fixed, but this fixes all the errors. And when a packet, when we finish, one of them sends a call clear, and every router will then wipe you off their booking table, their virtual circuit table. Like all the airlines, if you cancel, they'll remove you off, and that's it. They don't have your record anymore. Okay, so what's the time? Okay. Thank you very much, guys.